Yeah, hi everyone. Welcome back. So it's been like 5 days since I have not posted it my running CK. So I was busy with some personal work and was giving interviews. That's why I couldn't make videos. But nevertheless, let's start with where we left off. So what we have covered so far is blue, green, and color canary deployment. Also, we have covered jobs, cron jobs. Uh, so let's start with today with the network policy and Ingress, and then we will go touch upon persistent volumes and persistent volume claims. So yeah, let's start with network policy. So network policies allows you to control how pod can communicate with each other with other network entities. Okay. So regarding this entity work, if you refer to the documentation over here, network policy, so communicate with network entities. So we use the word entity here to avoid overloading the more common terms such as endpoints and services, which have specific Kubernetes connotations. So that's why I kept the word entities only. So yeah, that word uh, is a network policy. It allows you to control how board can communicate with each other. So definitions: ingress traffic. We have ingress and egress traffic. Ingress means traffic coming into the pod, and egress means so, uh, traffic leaving the pod. So why network policies? By default, Kubernetes allows all the traffic between the pods. So by default, if you create a pod, and then it allows all traffic between the pod. But by defining a network policy, you can restrict the communications. So let's say our team want to ensure that the front end cannot access the database directly. So only backend services can able to talk to database. You can define it. Uh, so that's where the network policy comes to play, where they allow you to define rules about who can send the traffic to a pod and where a pod can send traffic egress. So it allows the granular computation. You can define it on a pod, or you can define it on which pod to send. So are defined network policy are defined using pod selector, which pods the policy applies to. Policy type, it could be ingress or egress for both. Rules specify rules that allows traffic based on pod labels and pods. And it is important to note that policies denies all the traffic by default unless it is explicitly allowed. Okay. So example, allow API server to talk to DB server on port 3306. So this is like the definition file. And if you see under the spec section, we have pod selector. So this particular network policy is applied to the labels which applies to a pod which have labels server or DB. And policy type, it is for ingress only, and we have defined one tool for ingress. Okay. So ingress from pod selector. So it is accepting the traffic from API server. So from pod selector, this is a listing. And on port, this protocol TCP and port with receivers. So you can have another block which is egress over here. Uh, this egress over here. So it will be 2 here, and you can define on port selector IP block and all. Okay. So just to keep it short, I have mentioned this only. So above policy would allow any pod with a matching label in any namespace. Okay, so its namespace also any namespace. If a pod has this matching label, it can allow. You can restrict on a namespace also. So like label namespace selector. If the particular pod has namespace label as this, then only if the pod is like that namespace, then can allow me that. So we will come to this, and there is a my like common mistake that people do with defining policies. So allow external access. So if you want the external access to a pod, okay, external access from the pod, you can do this. You can mention to this over here. So common mistakes, dash creates a new rule. Okay. So from, and if I define like this, dash, so from pod selector, if we create this, then these are two conditions, okay, two or conditions. And below is, below means both are like and condition over here. Okay. So this is or condition. If the accept traffic from this TV or this pod or from this namespace pod. So this is, and if you want and condition, then you can remove this here. So that was a common mistake. And and if in exam, like if we forget the dash, then it changes the whole meaning of it. So need to be careful. That's why I mentioned. So these are or conditions. Either you can have traffic from pod selector or namespace, or this is means both pod selector and namespace. So Ingress, when you deploy multiple applications, exposing them to internet is a cost efficient as well as insecure, and becomes tricky. So without Ingress, you either have to use multiple load balancer service with which will increase cost. So if you are in like a cloud platform, then multiple load balancer service, okay. You can use node services service plus external policy, which leads to a complex configuration. You have to deal with DNS SLS certificates, routing logic separately, which is harder to manage. So this is where Ingress comes to rescue. It's an API object that manages the external access to services within the cluster. So it allows you to define rule for routing traffic based on the host name, URL. So this is a like a simple definition. So we have two components in Ingress, which is first is resource, Ingress resource, and second is Ingress controller. Ingress resource has these rules. These are the rules that specify how to route external traffic to internal service. And a component, Ingress controller, is a component that implements the Ingress rules. So this is definition for Ingress. This allows to route the like slash API or slash web to the services at port 80. Okay. And this is the rewrite target, means like each of the individual services are exposing at the service at the slash, so you have to overwrite it. So it's like people will call myapp.com/API, but internally service API service will be greeted with a like local or slash. It's really hard. So yeah, more on this. It's a vast topic, but I just gave the one we can have multiple research over happiness. Here it is. You can do host based also. So like if I have API myapp.com, if I have web.myapp.com, you can do that load balancing as well. So yeah, I think I will create a service. So far, like if this was topic, I need more hands-on. I will be doing that. But so I will be updating this as well. But I have kept it start. So let's go to persistent problem. So in Docker, when a container is destroyed, its data is also destroyed, right? So we all know that when working in container, when data is created inside the container layer, uh, when the container is destroyed, data also is destroyed because it's an ephemeral layer. Okay? So in order to persist the data, Docker uses volumes, uh, which are nothing but directories on host mounted onto the containers. Okay, which particularly is a bind mount. We have bind mount and volume mount. Volume mount is nothing but like Docker managed volumes, which are isolated from host system. So you can use bind mount or volume mount depending upon your requirement. And yeah, that's how Docker uses volume to process the data. But in Kubernetes, we need something more than this bind mount volume mount. So, but the concept remains the same. When the pod is destroyed, its data is also destroyed. Volumes allows data to process beyond the life of the pod. Okay, so how the volume works is we need to attach a volume to a pod and then mount to a container. But in the case of Docker, it was like mounting the volume directly to container. But we did in Kubernetes, but we need to attach a volume first and then mount it on the container. For example, in this is like we need to attach this slash data on a pod using host path field. So as you can see over here, we have named the volume and host path is this slash directory, which is the existing directory on a host. And then we are here in the specs.container mounting the directory on to the this slash opt4 directory. So that's an example. And limitation of host path is when working on a single works only on a single node cluster. But what if we require multi-node cluster, right? And host part leads to inconsistency because each node has its own separate slash data directory. So let's say you have a data. You have a file in slash data directory, let's say a.txt, and it contains some data, and now it is mounted onto the different nodes. So if one node's write to a data, another node's delete to a data, which can lead to inconsistency, right? So that is the limitations. Persistent volume, problem volume. So when working in lab setup using volumes, directly define we are volume we are directly defining the volume inside the pod specs, right? So we saw earlier that we are directly defining the volume mounting points and all inside the pod spec, which can be challenging if underlining storage is changed, all the pod definition needs to be updated. So let's say instead of mounting a host path, we need to mount like AWS EBS volume or NFS volume. Okay, so it can be challenging. So to maintain the volume definition inside the pod volume configuration inside the pod definition. So solution is to use persistent volume, which allows you to centralize and decouple storage configuration from the pod specs. Okay, and it's a cluster-wide resource that provides abstracted and reusable storage for user. So you can configure it with this access modes. These are three modes: read, write once, which means one node can mount, read, and write. Read only many means many nodes can mount, and in a read only type of setup, Read write many means many node cannot in a read slash write setup. Capacity is how much storage is available, and storage backend can be host path or talk about earlier methods or release volume. So this is our persistent volumes uh, definition. So here capacity is 1 GB byte, and read write once is the access mode, and host part is this, which is less data on our host uh, system. You can create it, you can get it, you can delete it. And what are claims? So persistent volumes and claims go hand in hand. So it's a request. Uh, it's a request for a storage by user or application. So now we have created like volumes, and now we need the user, the end user or application user needs to like have claim for that particular storage. Okay, so that's where persistent volume comes. The user don't deal with how the storage is provisioned, which usually is done by cluster admins. Okay, so they just ask for how much they need. Okay, so like we have separate team for managing like cluster related thing, and we have developers, right? So the developer can ask how much they need for their application, and Kubernetes will try to match the claim with suitable persistent volume. And once matched, the persistent volume, which is PV or PVC, are bound one to one. So it will try to find a PV that has equal or more storage than requested. And if it is matched, like access mode should be matched, volume mode should be matched, storage class should be matched, and it is automatically binded. And what if we require like if we have multiple suitable volume which can be bounded, then we can use labels and selector to target a specific PV. If no suitable PV is available, then PVC remains in pending state, and once the PV is once the matching PV is added, it's bind automatically. So that's the example of PV. Then one-to-one binding. A PVC is like is bound to one PV, and if a PV has more capacity than requested, it can be split across the multiple claims. So this is an example. Like claims request is 500 megabyte, and PV has 1 GB byte. Then PVC is bounded to that PV, considering that PVC wasn't able to find the other PV. Okay, so the remaining 500 is unused and unavailable to other claims. Okay. So these are the default like volume claim policy retain, which allows when PV remains even if the PVC is deleted. So like now it is bounded, PVC is bounded to PV, and if we try to delete it, then this policy helps us to retain the data or delete the data or recycle the data. So that's what volume reclaim policy does. So retain means admin must manually delete or reuse the volume. Delete underlying storage is automatically deleted when PVC deleted. PV scrub and reuse for future clean. So this is now deprecated. If you see in Kubernetes documentation, persist. And what the heck? System volume claims, yes. Search for claim policies. Reclaim, retrain, delete, and recycle. Recycle is deprecated. Instead, the recommended approach is to use the dynamic provisioning. So yeah, that's about persistent volumes and persistent volume claims. Okay. Next, what we are going to see is like storage class, not yeah. Website is also like I need to push this on the website. So that's all for now. And I need to draft my LFX like proposal as well. So let's see how I can figure out my time to give this like yeah. Bye everyone.